avoid overfitting in your machine learning models? It's a problem that many data scientists struggle with, so let's break it down. So firstly, what is overfitting? Overfitting is when a machine learning model learns the training data too closely, meaning it captures the random noise, outliers, and accidental patterns instead of the true underlying relationship we actually care about. This can make the model look extremely accurate during training while failing badly on new, unseen data. This is harmful because the entire goal of machine learning is to build reliable predictions on future data, not to perfectly remember the past. And an overfit model gives you a false sense of confidence while producing unreliable and unstable results in real life. When an overfit model sees unseen data, it effectively goes looking for the exact same feature patterns and combinations it memorized during training. But because the new data does not exactly match those memorized patterns, the model fails to recognize the broader structure and performs poorly. So to avoid this from happening, you're going to follow the next 3 steps. The first step is to reduce model complexity. This step is about limiting how complicated a model can become, so it is prevented from learning specific noise and outliers. Simpler models or tighter constraints work because they restrict how specifically the model can fit each individual training point. In practice, this can mean using shallower decision trees in a random forest model, limiting the number of boosting rounds in gradient boosting, or limiting the number of neurons or layers in a neural network. Reducing the number of features in your data or avoiding high-degree polynomial features can also help because, of course, each extra feature gives the model yet another way to overspecialize. The next step is to stop training at the right time. This step focuses on ending the machine learning training when the model has learned the main structure of the data but before it starts fitting tiny details. And early stopping is exactly this. This works especially because most machine learning models improve on general patterns first and then only later begin refining themselves around noise. So you monitor the validation performance during training and stop when the validation performance stops improving. This prevents any additional training steps from only benefiting the training data. The result is that the model is trained enough to become accurate but not so overtrained that it is fragile. And the final step is to improve your data quality and relevance. This step is about making it easier for the model to learn real patterns by reducing the noise and misleading signals in the data. Data that is representative of reality is crucial because genuine underlying relationships will appear continuously, while random coincidences only appear in limited or specific examples. So removing features that are unstable or leaky reduces the shortcuts that the model can rely on when it's training. Feature selection is the process of choosing a subset of input variables that contain the most useful and reliable information for predicting the target, while also removing features that are redundant and noisy. So feature selection is a great tool to avoid overfitting. And with these 3 steps, you can build machine learning models that are more resilient to overfitting. So don't forget to save this video for the next time your model is underperforming and follow for more. See you in the next one.